So first off, welcome everybody to the first Corda Bootcamp webinar. We usually run these in person. I'm one of the developer relations who does in-person training boot camps, but due to what's going on with the events, we've had to get a little bit creative. And this is good because it means we're able to get a whole load of Corda enthusiasts together to build something all at once. In the Slack channel, send your cheers, tweet it out. It's awesome. So we'll be asking for feedback at the end. Please let us know what you liked, what you didn't. And if you'd like to have more of these events, because we're ready to roll them out. I mean, I got the setup here. I'm ready to do more. So first off, I want everybody to look at the slide that's on there, right on your screen. Everybody jump into the Corda Ledger Slack. So there's a bootcamp channel. There's a direct bit.ly link on this slide here. Give you a second to type it in. Everybody bounce in there. Get hooked up with your IDE. So we got JetBrains, or we have an online pre-configured version at ide.corda.net and the project file repository. Don't worry, we're going to go all through this a little bit later. My Twitter is at Anthony Nixon or anixon604. Hashtags are Corda London. Okay, so before we get started, first let me introduce the crew that's making this possible. It's a big event, so don't hold back on applause and send them through the chat function. This will be our crowd participation trial run. We've got Robert in New York that helped set up this whole event. We've got Tiffany and Edgars from marketing who got the word out to everyone in such short notice. This was a huge pull, really getting everybody to go from in-person right to webinar format. And on the ground, we've got the DevRel team. So I have Chris and Peter, our Corda experts who will be fielding live questions and working behind the scenes with you to sort out any technical issues you might have along the way. And yours truly, I am Anthony. I'll be your host on this magical carpet ride to Corda blockchain glory. My goal is to do everything possible in my power to make this the best 2 hours of your week. No, the best 2 hours of your month. So I'll be keeping things rocking and making what is truly interesting topic the next level of awesome. This is meant to be super interactive. Obviously, we're not in front of each other, but I need you all to show some love and pump some fists through chat if you're ready to rumble. Logistically, let's get started. So we've got 2 hours, and over the next 2 hours, we're going to build a Corda app. This will be a simple token issuance app. But with the fundamentals you learned here, I guarantee you 100% you'll be set to take things further and build much more complex CorDapps. So it all starts here with the fundamentals. I'm going to start off with some really brief theory just to kick things off on how Corda can share facts between parties on a permission network. Then we're going to dive right into the code. Every CorDapp consists of at least 3 things: a state, a contract, and a flow. I'm going to tell you what those are. We're going to build each of these components in sequence using Java. Don't worry if Java is rusty, weak, or non-existent. I totally have your back here. So we're going to do it together and have a lot of opportunity to learn along the way. And finally, at the end, for the grand finale, we're going to spin up a mock network. Yes, I said that right. We're going to spin up a mock network and run our CorDapp and blow some minds. For questions, this is an important thing. Everyone has questions. Sometimes I have questions. Why is the sky blue? Why do fools fall in love? Regardless, when you have a question, we have 2 ways for you to participate. Enter in the WebEx Q&A. Note that this only allows 256 characters. So I'm really going to promote and really encourage you to go with option number 2. Post your question in the Bootcamp Slack, which is Slack channel is listed here on Corda Ledger. It's Bootcamp. Link is on the slide. When you post it in Slack, Chris and Peter will be answering as many as possible. At the end of every section that I go over with you guys, I'm going to pause to take some questions, field some questions that are kind of like general and that everybody will benefit from on air. But if your question goes unanswered for whatever reason, don't fear. If it's in Slack, we'll be able to get back to you, even if it's after the webinar. So a couple more logistic things. Whoa, we have 124 people. This is pretty crazy. For computer setup, again, there's some links related to setup on the screen right now. If you arrived early, you may have been able to snag IntelliJ or get the Git downloaded. If not, it's completely fine. We're going to go over a brief setup portion when we get to the coding section. So we'll have 5 to 10 minutes to walk everybody through downloading the project from Git and also like loading it into the IDE. I'm going to walk you through it, so don't worry about it. So with that being said, is everybody ready to rock? We're about to like start here. Slack.corda.net is where you can get to the Corda Ledger channel. You can also go cordaledger.slack.com. Sorry if I said that wrong. But yeah, so I don't know if any of you are having trouble getting into the bootcamp channel. If you are, post in the chat, like in the Q&A, and somebody will get to you. But oh, I see somebody sent out a rocket ship. He's ready to fire off. So some of you are getting in the bootcamp channel. But yeah, head over to slack.corda.net. It'll get you right into our pub Slack. And then from there, you're going to go into the bootcamp. So more people are kicking off and getting into the bootcamp. We've got a lot of people there. Okay, are we ready to roll? Let's go with some theory here. First slide gets exciting. So at Corda, we believe distributed ledger technology reduces costs and time to market while increasing the speed of business. I assume most of you have probably heard of R3 and probably heard of Corda by the fact that you're here, and we pushed that out, and we're really happy that you're joining us. But this is kind of like what drives us here. We understand that distributed ledger technology has a huge value for businesses, for society, for enterprise in general, and we built everything on top of that. We said, like, let's roll this out. If you are completely new to blockchain, let's talk about it a little bit. So blockchain 1.0, everybody's probably heard of Bitcoin. Maybe you've heard of Ethereum. So there's a lot of blockchain-esque concepts out there. But the thing is, in the early days, one thing that they were missing was basically what's on the screen. So these sort of things, they didn't have an identity. You wanted to participate in blockchain. Sure, you had a wallet, but you had a pseudo-anonymous key. Who are you? And that was kind of beneficial for disrupting financial markets or trying to kind of like do peer-to-peer token sort of value transactions. Like that's fine, but it's not really suitable for business. Privacy, blockchain 1.0, permissionless public blockchain networks have what's called a global record. So they use a gossip protocol, which is basically anytime you do a transaction or do something, it pushes out to all the actors, to everybody on that network, and everybody has a single shared view of all the transactions, right up to the initial one that kicked off the blockchain, which is the Genesis block. That's good in some ways, but not good for business. Speed. Basically, if you've done Bitcoin, you know that it takes a little while for things to kind of hit that probabilistic finality. And integration, well, yeah, there's a lot of Ethereum projects out there. There's a lot of Bitcoin projects out there, but it's really hard to integrate with legacy systems or with your corporation or enterprise. So these are some limitations of blockchain 1.0, and we can say that we can evolve on that. We can go further. We can get to the point where we can leverage the blockchain properties and have them really functional and really working and kind of benefiting us right now in our workflows, in our enterprise, in our companies, in our transactions. And this is what Corda offers. It kind of offers this sort of like next level, the 2.0, which expands the use cases and gets everybody on board through these unique properties on the screen. So we've got the consensus. It's the same as blockchain 1.0. The parties that are looking at a particular transaction or looking at a fact, they're guaranteed to be seeing the same source of truth, but we take it a little bit further. So it's not a completely public record. You'll see that we also have privacy, transactions and things that go between counterparties are need-to-know basis. What that means is that, like, if me and Bob or me and Alice, we're all part of the network. So there's 3 of us. If I have a transaction with Bob and only Bob, does Alice really need to know about it? Not necessarily. And if that not necessarily is a no, she will not know about it. So we enforce privacy using peer-to-peer transactions. peer-to-peer communication, point-to-point over TLS. Also, the actual records are only stored by the parties that are relevant. And I'll talk about that later when we get to states. Integration, like I said, this workshop here, this bootcamp is going to be in Java. And if you know anything about Java, it integrates well. So if your IT team at work is there, if you have an IT team at work, they're probably functional on Java. Kotlin. This is a really big sort of like strategy decision in the sense that we wanted everybody to be able to use this technology. We wanted companies and corporations to be able to go right out of the gate. Identity is another huge one. It's talking about legal agreements. It's talking about taking existing corporate or enterprise workflows and then kind of being able to enforce those in the real world. So when I do something on Ledger or do something in a digital space, you know, that has real world consequences, and the real world doesn't deal with pseudo-anonymous identities, etc. The real world deals with legal identities. So we have a network that you have to onboard and go through a KYC process to get your certificate and your key. Every actor or counterparty on a Corda network will be tied to a real world entity. That's identity. Speed. I'm going to show you how Corda is able to blast off your TPS, transactions per second, much, much higher than what was traditionally possible using something called a notary. Oh, keyword. We'll get back to that later. And it's open source. So the thing is, when we develop an awesome platform that everybody jumps on board and everybody wants to use, well, there's something what we need to consider. Like, what if R3 disappears? Well, we're not going to disappear, but if we did, the platform is open source. It's available for you to keep. It's available for you to modify and keep building on, even long after corporations might not exist anymore. So another thing is that we get a lot of feedback and we derive a lot of intuition, sort of like developer experience and feature ideas through the open source community. And we have a lot of public contributions. So if you want to contribute, like, you can hit up our GitHub, you can start getting involved as well in developing the next gen here. So I have a question. Will we get a free certification voucher? Yes, there is a free certification day on March 31st. So once everybody goes through the training today, you're going to realize that, hey, I feel confident. I'm ready. Like, you're going to be on your way to certification. Now put in a little bit of practice, do a little bit of brushing up, and I guarantee you're going to ace that and get that certification. So that's going to be on March 31. Look at this, one app, 3 days, 3 people. When we were talking about integration on the last slide, part of it was, you know, like getting time to value down. Let's get this app deployed. Let's get it going. So Corda was originally envisioned to create, like, be simple enough, be intuitive enough, have the APIs tuned well enough that one app could be created in 3 days by 3 people. Well, I don't like this slide because it's old news. This is defunct. Today, we're going to do one app in 2 hours with 130 plus people. Yeah, you'll see it's going to be easy. We'll see how to fire through and build a working Cord app really quickly, and you'll really appreciate all the thought and effort that's been put into the developer experience and how you can get apps deployed quickly. So let's visualize what we've been talking about. These are parties. This is Acme Corp. I don't know if anybody remembers Looney Tunes from back in the day. I remember Looney Tunes. I really love that show. It was hilariously funny. But you know that those guys didn't really trust each other, right? So, you know, like distrusting parties, but they still have to interact. There's still things that are going on. So this could be seen as like a Corda network. I'll give you the basic rundown of what we're seeing on the screen. The red dots indicate counterparties, or nodes as we call them. These are legal identities. Each of these counterparties would have been onboarded, basically going through a brief KYC check to make sure they're legit, they're tied to a real world entity. They would have been then issued a certificate and public key. Everybody on this list will also be registered in what's called a network map cache, which, think of it just like an address book. So we have an address book of where everybody else resides on the network. There's a little like dot here, or like not a dot, but sort of like a ring, looks like a baby toy. I think I used to chew on one of those when I was a little kid. That is called a notary. Let's click back and forth. That's a notary. That's a notary pool. So a notary is what we use to enforce uniqueness consensus, because one of the biggest things that blockchain solved in general was the double spend problem. How can you keep records? How can you keep digital facts, consents, like keep the integrity and make sure that everybody has the view of the same thing, without some sort of check on double spends, etc. So that's kind of what Bitcoin 1.0 solved. That's kind of what blockchain solves. But there's different ways to accomplish it. So Bitcoin and some of the permissionless networks traditionally have used proof of work, which is sort of like getting everybody in the network all together to kind of like cast votes. Think of it like that, and we say like, is this real? Is this the real state of the world? And if we have 51% of everybody, then we can say, yeah, this is true. This is true. So this is what we're going by. But the problem with that, like, as you can see, is when everybody's involved in this sort of like reconciliation or this checking, it becomes really, really slow. So what we did was we created this concept of a notary. And think of the notary as basically a trusted party that is going to be monitoring transactions for double spends and ensuring that anytime a particular fact is proposed to be modified, that this is basically done on a fact that hasn't been modified before. So, geez, I just can explain that completely confusingly, but I'm going to get back to it later and explain in much more detail how this works. But basically, the notary is going to be checking for double spends. It doesn't have to be a single server, though. It can be a notary pool. And the notary pool, you could have hardware contributed by Tweety, by Acne Corp, by Donald Duck. So this is sort of like everybody, or like the consortium on the network, can sort of contribute to this. And within that notary pool, you can run a consensus algorithm, which is pluggable. It can be BFT, but it can be something else like Raft, etc. So that's just keeping that into consensus. But the notary pool will basically be an integral part of our Corda network. So now that we have our Corda network and we have our parties, how are we going to do things on this? What does it mean? And what it means is we can start representing shared facts or representing data on this network to use in transactions. Right here, Wile E. Coyote is thinking to himself, I need a catapult. I've been like sort of like scheming and making plans on what I'm going to do to Roadrunner, and I want to catch him with a catapult. Luckily, Acme Corp manufactures catapults. So we can take this concept of a catapult and we can kind of like represent that on Corda. We can represent that as a state. We call it a state. So a state is basically an encapsulation. It's a class that represents some fact that we want to write onto ledger. Think of a state as like a database record. What do you have on your database in your company? What do you have on your database at home? It could be anything. It could be students, right? You're running a school and you have a list of students. Every row on that student table represents a student. That student has maybe like a name. It has a date of birth, has a like height, a weight, or whatever. I don't know why they would keep those properties on a student record, but whatever it is on that table, you can represent as a state. And this is it. So this state represents a catapult. Now, if we look at this little state here in the properties, product, amount, price, seller, buyer, just mentally rotate that. Like just turn it sideways in your mind and you'll see that those could be sort of like columns of a table entry. So, this could be a product table, and each row has a product, an amount, a price, a seller, a buyer. So it's really intuitive to go from something like a fact stored on a traditional database to a state model. And this is what the code will look like. We're going to go through this together. But basically, we take this shared fact, we take this database record, and we turn it into an instantiation of a class. So we're going to be able to program this later all together, and you're going to see how easy it is. But basically, this is how the facts that we want to share on the Corda network are created. So we have this state that's representing a catapult going to Wile E. Coyote. look at this. Next thing that I want to introduce is a contract. If we are sending a state to Wile E. Coyote and we're doing anything on Ledger, say like a creation of a state, a modification of a state, or a destruction of a state, anytime we're changing a shared fact, we need some way to enforce business rules or logic on how we are allowed to evolve that state, how we are allowed to make changes that are going to be used to create transactions on the network. And that concept of, constraints on evolutions or on modifications of states, that's what we call a contract in Corda. And this is the code. And think of a contract as just basically a checklist. I want everybody to mentally picture this. You're sitting in your favorite factory. I don't know if it makes Nike shoes, or I don't know if it makes toys or iPads, but you're basically sitting there like in a factory, and you're in front of a conveyor belt. And the conveyor belt has some sort of like products that are just sort of like drifting along. They're coming along the conveyor belt. You're sitting on the side, and you have with you a checklist. Now, as each product comes by you, you'll notice that they come in groups of two. One of them is sort of like an initial product, and one of them is sort of a product with a small change to it. So think of this shoe, like you have two pairs of shoes coming down the conveyor belt, like towards you. I'm like chilling, it's Nike. And then what I want to do is I want to evolve this. I want to say like, okay, the first shoe, like is last year's model, and then the second shoe is this year's model. Now I look at my checklist and I say like, is this evolution legal? Am I allowed to do this? And some of the things that I might have in my contract is like, okay, the shoe has to have the same brand. So the shoe from last year, the shoe from this year, obviously it's the same brand because we're in this factory. So I check that the label says like Nike on both of them, and it's like, yes, let's check. So look at the contract code here and visualize. Imagine there's these constraints or checks. I look at this other thing and I see, okay, so the first shoe is gray and the second shoe is orange. Then I look at my checklist and I say like, is there a constraint? Is there some rule that says I can't turn this into an orange shoe? And it's like, no, like you totally can turn it into an orange shoe because, it's that's what happens from year to year. So you have all these like basic like modifications or transitions, and you're just basically creating checklists or business constraints. So this is something that you would work with your consortium, your counterparties to create consensus. Like, how are we going to constrain our modification on the facts, on when we want to change the state of the world? What are the rules that we're going to follow? That's a contract. The next thing is, let's recap what's happened up to this point. We had a catapult state. Acme Corp wanted to sell it to Wile E. Coyote. They did that. They both basically approved it and signed, etc. Now the thing is, what's to say that Acme didn't sell that same catapult over to Elmer Fudd over there? And what's stopping it is basically the notary pool, like I mentioned before. So the notary pool will check inputs just using a unique ID. Every single state that is ever placed on Ledger will be uniquely identified, but I think of it as a string, just like a string of characters that is completely unique. Now, if I want to create a transition, like change an owner, or like with that Nike shoe conveyor, if I want to change the color of that, we will take that input state and we will say that it's historic now. We'll say that we're no longer going to use it. We're going to consume it. And then we're going to create an output state. So what the notary does is every time there's a transaction, the notary will check to make sure that that input state, that original instance that we're proposing, has not already been used, has not already been consumed. It just stores a list basically. So that's like how that works. And then if it passes, then the notary will sign it off. This is how we completely avoid that whole proof of work nonsense and are able to kind of like get transactions through really quickly. Now there's a trade-off here, and you can kind of think of it. Number one, the notary becomes like a trusted party there. Like the notary, we have to trust the notary or notary pool to not be cheating, to do things correctly. And this is fine because in the real world, we have these natural trust structures. If we're a banking institution working with a consortium of banks, we have the central bank who we might trust, or we're like basically delegating trust to in a manner anyway. Or if we want to work with amongst ourselves, there's a certain level of trust that we've all coordinated together to put this network to join. We've been all identified and KYC'd. And then we can all contribute to a notary pool, and we're going to say we're going to delegate trust there. So this works perfectly well in real world hierarchical business structures, which is amazing. The last thing that I want to talk about before we start moving on code and start to do really fun things is if we have these states, these encapsulated shared facts, the things that we want to represent on network in transactions, etc. And we have contracts that are able to govern their evolution over time. What do we do with that? Like, how do we actually make this happen? How do we glue everything together? And how do we propose transactions with counterparties? How do we send messages across the network? How do we do little like housekeeping things or things on the side, which could be like querying an internal database or like using an Oracle, etc. How do we do these things? And the answer is flows. So flows, you're going to see later, they're a structure that is unopinionated about what you can do with them. But one of the primary things that they're used for is for building and proposing transactions, sending those transactions to counterparties, and then finalizing those transactions, having the notary sign off as valid, and then having those written to the corresponding ledgers. So we're going to show you how to use flows. This is what the code looks like. It might look a little bit like confusing at the moment, but when we go through it step by step, it'll all make sense. Because what happens is Corda is able to abstract away the complexity of the DLT property, the complexity of key management, the complexity of network messaging, of all these things that we want. We need all these features, but yet as CorDapp developers, our real primary concern is kind of like building that enterprise or building that solution based on the constraints of what we're trying to represent, based on the facts we're trying to share. So we've created an interface that is really easy to use and allows us to basically use flow libraries, like pre-compile, like basically preset libraries of functionality that's often needed for DLT. And you can basically call them and execute complex algorithms with single lines of code. So the flows, when we get to them, they're going to be really, really fun. This here is what a transaction could look like. I'm going to say right off the bat that Corda uses something called an unspent transaction output model. I've kind of been hinting to you guys and putting it all together piece by piece what that is. I haven't named it yet, but that whole idea of taking inputs, marking them as consumed, and then creating outputs, this is the unspent transaction output model. And what it means is that we can easily control and validate and protect against double spends by checking inputs. And we have flexibility to kind of like do many different business cases by creating particular outputs relative to what we're trying to accomplish. Now, if we're doing something like selling a catapult from Acme Corporation to Wile E. Coyote, you can see here that Acme had this original ownership state. It already had basically a record on the network that it owned 2,048 catapults that had a price of $2,500. Acme wants to sell this to Wiley, so what Acme did was consume this, use it as an input, and generate two outputs, a catapult of one with a new buyer being Wile E. Coyote, and a catapult instance with an amount of 2047 with no buyer. And that's basically the change. So that's the leftover catapult after Wiley has taken one. So this sort of thing where you have inputs and then outputs, the legality or what you're allowed to do in a transaction is defined by the contract. So this contract would have said something like the amount of catapults as a sum of the outputs. So if I add up the amount of both of the outputs, 2047 plus 1 has to equal 2048. So that's something that would be in the contract. but we're going to get into how this works in detail as we go along. Up to this point, how is everybody doing? How is everybody feeling? Are people feeling comfortable? Are people feeling a little bit lost? Let me know your feedback. Let's push that out into the Slack channel there. I know it's a lot to take in, but I'm also going to tell you, oh, I see thumbs up. That's awesome. That's awesome, Cha. Thumbs up to you too. Well, oh, thumbs up from Roman also. Okay, so for those that are feeling a little bit iffy, I'm telling you now, like it'll start to clear up. It'll start to clear up. So everything that we build on today is going to reinforce each other. So as we go through the code, I'm going to give you more tidbits. I'm going to give you more hints, and it's going to sort of like start to glue together what we just went over on this like brief theory. It's really hard to kind of show and articulate things just from a few PowerPoints. It's all about doing. That's what we're here today to do. So now you see I'm on a slide. This is called the Corda network. So this little section of slides, I'm going to tell you, once you've designed a CorDapp, or once you've got your business consortium, you've got all your buddies together, you're about to like basically take off into the next level. How do you deploy this? What are your options for setting up a Corda network? So Corda is a private permissionless distributed ledger technology platform. And you can basically take the open source version and create your own private network using your own hardware with your buddies. That's totally fine. But at the same time, we have other options. What if you want to interact with other business verticals, or what if you want to sort of like have that, not have to worry about maintenance or network management? We have something called the Corda network, which is kind of like a global network, which is administered and managed by a nonprofit in Holland. So regardless of what happens to R3, it's gonna, like keep going on. We are maintainers right now, but we don't have, basically we just have seats on the board. So this is completely a autonomous organization. And this is where you can onboard to sort of like get set up with your corporation or your business consortium. That's one option. We have some other options too. Testnet, we're going to be rolling out a lot of information about Testnet. So you want to do a live trial, or you want to start getting going with your business partners, but like you just want to keep it in a small group, you just want to test features, go to Testnet. That's going to be a deployment option. It's free to onboard there. And what it's going to allow you to do is basically roll out. I mean, there's no SLAs here. There's no service. There's no guarantees for what you run on Testnet, but you're going to get a real world experience. So that's an option too. If you want to set up, like I said, your own little like private thing going on with your buddies, go to the docs.corda.net. So I recommend everybody bookmark this site, because not only does it have information about how to set up a Corda network, but related to what we're doing today, there's also going to be information about like key concepts and things I covered today. And there's going to be the API reference documentation. So this is where you can go to kind of like brush up and find those little tidbits, those little hints. And when you're going for certification, check out docs.corda.net as your primary resource as well, because that's going to help you along the way. Then here it is, the big awesomeness. Let's get to it. Let's get going on this journey, the magical ride to CorDapp glory, like I promised you guys. Here's the book, the GitHub link right here. I'll give you guys all a second to copy this. Go to this URL. If there's any last minute questions, or if you're having problems, please post them in the Slack channel. We've got the bootcamp channel live right now. Our number of attendees is amazing. So we have 138 people that are all going to build. We're all going to do this all at once. This is going to be the biggest coding sesh ever for Corda. Hope everybody's got this URL. I'll post it again in a second. Now I'm going to go over the project structure, get into the code and the IDE. So don't worry about memorizing this or anything, but I just wanted to point out a few different resources that are going to be available to us, like on the side. I'm going to be your primary resource. So I'm going to be basically walking everybody through the exercises, but the project will also contain an example implementation of a parallel CorDapp, which won't be the same one that we're working on. I'll show you where this is when I open up the IDE. There are also several key web resources that you guys are able to utilize throughout this session. Like I said, we've got docs.corda.net. We've got the API docs at docs.corda.net. There's a cheat sheet. I love this cheat sheet. So when I started off doing CorDapps, I brought out this cheat sheet, and it basically gives you all of the different primary classes that we're going to be working with. When you see something in a basic CorDapp, I guarantee you most likely an element of it or several elements of it will be on this cheat sheet. So you could have that by your desk or on a little like side window while we do this. And then Stack Overflow as well. So for any like super crazy questions out there, we have Stack Overflow. There's a lot of questions that have been answered. So the first thing we're going to do to get set up is, if you don't have an IDE yet, go over and download IntelliJ Community Edition. If you are using the IDE.corda.net, the online Docker version, you don't have to download any project files. It's already available for you in the online instance. But if you're using IntelliJ, then go clone the CorDapp. And this is basically what I'm going to do. So don't memorize like these steps, because I'm about to walk you through them. But I will show you how to import the project. I will show you how to link it to Gradle. And I will show you how to make sure that everything's functioning properly. So before we get to this, somebody asked a question: how is Corda different from Hyperledger Fabric? Corda is different from Hyperledger Fabric because it's a little bit, we were built from scratch, basically ground up to suit the needs of enterprise businesses, of enterprise workflows of big corporations. Hyperledger Fabric kind of like split off from Ethereum. So they sort of like took an existing permissionless blockchain, modified it in a way to sort of like constrain it to the needs of business. Remember those properties that I talked about earlier, such as like privacy, et cetera, identity, et cetera. So they were able to sort of like take that existing blockchain implementation, constrain it in a way that's functional for business. They're able to do point-to-point transactions through something called channels. But the thing is, all this is sort of like a hack on top. Corda, we took the needs of customers, we listened to the community, and then we built from scratch to basically address the properties of business. So that's the main difference. And we'll get into some more small differences as I go through the code. But let's kick it off now. I'm going to walk you through what we need to do to get set up. And in the Slack channel, yes, we can use VS Code. So the online Docker version, sorry, somebody just asked if we could use VS Code. The online IDE.corda.net is actually VS Code. So that's totally fine. Let me share my other screen. I'm going to share my terminal here so I can show you what's going on. So bear with me for 1 second. Let's see here. What are you guys seeing? You guys are seeing the GitHub. Okay. So I'm right here at the repo. This has our project files. This is what we're going to be using in order to build the CorDapp. There's a big green button on the side. It says clone or download. I want you guys to grab this. So if you have a GitHub account already, you can just copy that link. If you have no GitHub account and you don't, like it might be a little bit time constrained to set up a GitHub account right now, but you can either go to ide.corda.net where the files are preloaded and ready for you, or you can download the zip, and the zip will have all the project files as well. So what I did was I clicked the copy there. Then I'm going to go into my terminal. So launch a terminal instance, everybody. I'm at my terminal. I've got my little working directory, London Bootcamp. Type in git clone and then paste in that link. Paste in that link from the repository. When I hit enter, magic's going to happen. So going over the internet right now and downloading, grabbing all those files. If I list that directory now, I can see the Bootcamp CorDapp has been downloaded. Once I have that downloaded, let's go to IntelliJ. We're going to be opening it and importing it. Yes, I will be explaining the concept of states and flows during the coding session. Somebody just asked that. So everybody launch up IntelliJ. You'll see my window switch. I will be sharing with you IntelliJ in a second. Why is my Slack going? Technical difficulties, of course. Okay, in 1 second, or actually 3 seconds, 3, 2, 1. Do you guys all see my IntelliJ? Yes. This is where you want to be. So everybody follow along with me. Get your IntelliJ open so you're at this little like start screen here. Once you're at the start screen, I'm going to do this slowly so we can all do it together. Let's click on import project. We're going to import what we just downloaded. Once we have selected import, we're going to get an option to look for the project that we just downloaded. Now, I don't know where you guys put it, but for me, I put it in repo. I put it in that nifty directory, London Bootcamp, and the name is Bootcamp CorDapp. So once you get to Bootcamp CorDapp, click on open, and you should see this. So there'll be a pop-up. It's going to say, create project from existing sources or import project from external model. Now, Corda, for dependency management, we use Gradle, and you're going to see how that's really flexible and easy to use. And the main thing is that it's going to download automatically everything we need to get this Corda live, up and running. It's going to handle all the dependencies. We won't have to do a thing. But the thing that we really have to focus on is making sure that we import it. So everybody select Gradle, and then click Finish. When this happens, everybody keep an eye out at the bottom right of the screen. You're going to see IntelliJ IDEA found a Gradle build script. This is a really important part that a lot of people miss. We need to click import there. So go to the bottom right and click on import Gradle project. Once you've done that, you'll see that there's some stuff going on at the bottom of the screen. It says Gradle configuring build. If I click on this, there's some background tasks running, et cetera, et cetera. If you have never ever launched a Corda project on your computer, like opened one up before, it might take a little bit of time. So as long as you have that stuff going on at the bottom right, just keep waiting. I'm going to give it a little bit of time here so everybody can get that downloaded, because depending on your internet connection, depending on like how many cat videos you have going at the same time, this could take a few minutes. While I wait for everybody, I'll start kind of answering some questions and fielding things. So somebody says, what needs to be done in VS Code? So in VS Code, if you're running through the ide.corda.net, the online version of VS Code, nothing needs to be done. It's all there. If you are running on your own version of VS Code, the best thing to do is to go to the plugins and search for the VS Code Corda plugin. So that'll hook you up with all the extensions and plugins you need to basically handle the dependencies and do things with the CorDapp quite easily. It also has baked in some extra features you can play around with. So that's one of our initiatives, is we're launching plugins for the different IDEs. Okay, so now everybody click on the package that says Bootcamp CorDapp, and then open up source. And how we know that this has worked, that this import has happened correctly, is we're going to see these little blue squares on the main and test packages. If you do not see these blue squares, never fear, I'm here to help. What that means is that Gradle didn't import correctly. Maybe that little pop-up never happened, or something else went wrong. The easiest way to fix this is we can import the build.gradle manually. So if you don't have these two blue squares on these packages, click on build.gradle, right click on it, and then near the bottom, I mean, I don't have it because I already imported, but you'll see something that says import Gradle. So if you do that, you'll basically start downloading all the dependencies and everything will be good. Just had a coffee. Okay. Is everybody good? Is everybody good? Let's hear some like feedback in the bootcamp Slack. Everybody's set up. Do you have the blue squares on the main and the test? Yes, yes, yes. Awesome. I see some pluses. I see some good. Yeah, I have it set up. Awesome. Awesome. You guys are the best participants ever. Okay, we'll give it 30 more seconds for everybody else to catch up. And then we'll be ready to bounce. So I'm going to walk you through the project structure and how this is going to work. To build our CorDapp, we will be using some preloaded files. We're going to be using basically some templates or some scaffolding, which will include all of the different components we need. So if you expand that bootcamp package underneath the main module, you'll see that there's a token state, there's a token contract, and there's two flows. This is exactly what we're going to be using to create our CorDapp. These are the components. We've got the state, the contract, and the flow. Now, when we do these live in person, when I issue these bootcamps, we use a test-driven development methodology. What it means is that we've created under the test module in the bootcamp package tests for each of those components. So if you open one of those now, you'll see that there's a test class with some commented out tests for specific components of that class. So generally what we do is we open up the template state or the template contract or the template flow, the scaffolding, and we ask you guys, okay, can you like uncomment the first test and make it pass? Can you like modify that particular class so that the component that's being tested is there, conforms to it? So we incrementally build up on that. Now, because we're a huge group and we're all building together, I'm going to change the format a little bit. I'm going to peer program with you guys. So we're going to program together at the same time and taking little breaks to explain what's going on, going nice and sequentially. And then we're going to pass these tests all together, like after each component. So we'll run them all at once. But I'm basically going to point out in really detailed, specific manner, like what these tests are doing, like what component is this checking for? Why is this needed? And it's going to really build an understanding of what's the minimal components or the minimal things you need in your particular class to build a CorDapp. And then on top of that, it's going to allow you to visualize like how this can be extended, what you can add on top. So if everybody is doing well, let's open up the state. Let's reiterate what we're going to be building here though first. This is our CorDapp, the token CorDapp. We'll have that state that defines what is being transacted. Then we'll build a contract that validates the evolution of that state or anything we want to change. And then we're going to have a flow that ties it all together and basically allows us to create transactions. So that's what we're building. And now it's time to blast off. Okay, this state, does everybody remember what this is? It's a shared fact. It's a database record. It's something we want to represent on Ledger. Right now, all I have here is an empty class. There's nothing going on. Exceptionally boring, right? But how are we going to say that this is a Corda state? How are we going to say that this is one of the things that we're going to be sharing on Ledger? And the first thing that we're going to do is that we're going to implement contract state. Wait, I see that some people are having issues with the default bootcamp branch. Okay. Yeah, so the message in the Slack for those that haven't joined the channel is that some people are having issues with the bootcamp branch v4. So the recommendation is if that branch isn't working, please switch branches to the v3 version. And the way that you do that is git branch, or sorry, like git checkout and then that branch name. Chris and Peter will be able to help you input commands in the Slack channel for that. Okay, back to this state. So contract is an interface which is going to identify to the Corda platform that this is a contract state, that this is a contract state. Let's bring this up. So I'm going to shift. That'll open up a search window, which will allow me to search basically all the classes I have available to me. So click your shift, or just follow along on screen to what I show you. I'm going to open up contract state and view what's in it. So this interface has one property, and that property is a list of participants. So participants, we're going to go into detail what that is, but the participants are basically going to be the parties that are relevant to a particular transaction, to a type of evolution of that state. And anytime that state changes, these participants will get a ledger write update. They will be part of that need to know special group. So that's the one thing that Corda forces us to implement when we implement a contract state. You'll see that now I have a red squiggly line after I implemented this interface. What you can do to autocorrect that, if you're on a Mac, click Option, Enter. If you're on a PC, click Alt, an Alt Enter? I'm pretty sure it's Alt Enter. So it's either Alt Enter or Control Enter, but you'll basically get an autocorrect. You'd also get it if you just hovered over it. For those on Visual Studio Code, just hover over the error. It'll ask us to implement that mandatory getter, the method for that participants property. Remember that the contract state enforced that we needed a list of participants. So now here we have an actual valid Corda state. Nothing's going on. Corda will recognize it as a state, but we're not storing any information. There's nothing useful about this. So what we need to do is create properties. We have to create actual pieces of this record that we can instantiate, actual facts. To do that, it's just basically what you would do with a regular class. We're just creating a model of this record. So in the token state instance, just as a little spoiler, what we need is we're going to need an issuer, an owner, and an amount. An issuer, owner, and amount. So I'll just create properties. So follow along and just type in some properties here with me. When I get my modifiers, I don't like them like that. Okay, I got a private final. I got a private final party. I love parties. I got two private final parties, and I got a private final int amount. So this could represent a token state, because any token that I ever created would have perhaps an issuer, an owner, and an amount, right? Like those are things. If it was $100 representing, or a value of 100, I could issue that. I'd be the issuer. It would be held by an owner. But this goes much far beyond. So I want to show how you can expand this. If you were creating your own CorDapp, it could have been anything. Like if you want to sell sporting goods, right? Instead of putting issuer, owner, and amount, put in what's relevant to your particular CorDapp, your particular case. So if I was selling sporting goods, I could put in private final string sport or something, right? So this is basically the sport that this good is tied to. I could put in private final string product. So what kind is this? Is this like a basketball? Is it like a volleyball? Is it a golf club or whatever? I could put in a price. I could put in a price, and then I can put in a party just like before. But instead of saying like an issuer, I could have said something like a store and then like a buyer or an athlete or something. So anything that you want to represent, you can do it with a state. That's really intuitive. That's like so simple. It like blows my mind. But you notice that I kept using this word party, this class party. What is a party? Well, remember that when we talked about the network design and we actually showed you Wile E. Coyote, like Elmer Fudd and like Acme Corporation, right? We said that these people had legal identities, they had presences on the network. How do we deal with that in code? Like, what does that mean? So what we have is this class called party, and I'm going to dive into it. So if you hold down Control or hold down your Command key on a Mac and go over that class and click on it, you'll be able to upload party, and you'll see that this is really just like a wrapper that's containing a Corda 500 name, like a common name, like what is this organization? Who are these people? And a public key. So with that information, with this information in tow, Corda is able to basically do things like go into the that network map cache that I talked about, that address book, and be able to find this party on the network and direct a message to it. Corda will be able to do something like like open up a session, which is a direct connection. Corda will be able to do things like tie a party as a participant in a state, etc. So this is the way that we're able to interact with actual real world counterparties through the code. So that's what party is. So we're at the point where we've created the properties. So anytime that this state is shared or modified or changed, it's going to show and have access to these different properties that we're able to like look at. Think of them as database columns. But we need a couple other things. So click Alt Insert if you're on Windows, or click Command N if you're on Mac, and you're going to get this handy little IDE tool, which is going to allow us to generate things. And we need a constructor. So the constructor is going to allow us to instantiate versions or instances of this particular class. So we can create we can create as many token states as we want by constructing unique versions of them. So that's one thing. And the other thing is, once we have one of these states instantiated, once we are using a token in a transaction, etc., and it's on our ledger, like we own it or we have access to this record, how do we actually grab those properties? We need to also create getters in Java. If you're using Kotlin, then the getters will be automatically generated for you. You don't have to explicitly do it. That's just a Kotlin thing. But this is having getters is going to allow us to access these properties and read them and make use of them, and also use them in our contracts, which I'll show you a little bit later. I hope the font size is good for everybody. If anybody has problems seeing it, etc., just please post. The last thing that I want to talk about here, there's a couple more things, is one, is why did I put in these private final modifiers onto the properties? This is like a nerdy programming thing, but it's basically good code structure and good habit, because remember I said earlier that in interacting with these states and making use of them, we're going to use the unspent transaction output model. So we are going to have an instantiation of a state, and if we want to change that, if we want to like change the owner, we want to change the amount and make any modification, we're not going to actually edit that particular state. We're going to consume it. We're going to use it as an input, and then we're going to create a new output with the desired changes. So the fact that states are completely immutable in the UTXO model means that we're never going to change these properties. So just to remind ourselves, we can put private final and say that these properties will never be explicitly changed. They're immutable. So we're almost there. The state is taking shape. The next thing that we need to deal with to make this state useful is the get participants method. We have implemented the getter. We're saying like, yeah, we're a Corda state. We have participants. We're going to be able to send you a list of participants. But right now it's null. We haven't actually defined who those participants are. So let's talk about, again, just to reiterate what the participants means. So when you create a state, whoever's in this participants list, whatever parties I put in this list, they will be notified of any creation, modification, or destruction of this state. Awesome. That means anytime this state is used in a transaction or anything happens to it, this party will get notified, like the whole list, the sum of the people in this. So intuitively speaking, if we were going to basically be issuing tokens and the parties that we have involved here, like it looks like the issuer and the owner, then what would we do? What could we put in the participants? Well, we could put in the issuer and the owner. So that's what I'll do here, and you guys can follow along. You can use different collection utilities, or you can instantiate manually, like an instance of array lists or some other form. I tend to like immutable list of, so that's a really easy one to use. But I'm basically creating a list in here that's going to return the issuer and the owner. So with that being said, we fully built out a shared fact. We fully built out a contract state that's valid in Corda. Now, the one last key thing that I want to tell everybody is, remember I mentioned in the theory introduction when I was talking about states a little bit. So every state has to be constrained by some sort of contract. So how does Corda know which contract is associated with which state? And this is where you have this special, like, nifty little annotation right at the top, which is commented out. See this here? It says at belongs to contract. So one hint here, which we're going to be using, is that to quickly comment and uncomment things on your IDE, if you're on Mac, hold down Command and then hit /. And if you're on Windows, hold down Control and hit /. So this is going to allow me to do this. Like, I don't think your computer will do like mine does, but that's going to allow us to do this. And what this is saying is that this state will forever be tied to the token contract, which we'll build next. And that contract will follow the state along its journey through its life cycle as bytecode, and will always be, every time that that state gets received by a node, by one of the actors on the party, like whether it be a transaction or whatnot, that bytecode will be unraveled and the contract will be run against this particular state. So this is all it is. Don't mind the squiggly line right now because we actually haven't built the contract. So that's why your IDE will be complaining. But I want to see a show of hands. I want to see like the Q&A light up or the Slack channel go booming. How are you guys feeling? Are there any questions about contract states in Corda? So I'm going to open this up to some question and answer regarding contract states. Let's just fire off those questions. Let me know what you guys are thinking. This is a fundamental thing, and it's going to basically lead us into the next section. So I don't see any questions yet. Great. That's not a question, but I love it. So I'm getting some good feedback here. Some people are totally on board with this. For those that are a little bit iffy, let's just visually look at this. I want you to cognitively focus on these properties here, mentally rotate them in your mind, and then think of them as like, oh, hey, this is a table entry. This is a row. This is how we can represent things that we would have stored traditionally in a regular database, but through an actual class object. So that's basically the way to think about it. It's something that you'll intuitively start to grasp as we go through things and as you start working more with CorDapps. But this is the basic fundamentals. Okay, so since there's no more questions, we're going to test this. We're going to see if the live code that I did actually screwed up or not, or I don't know. I'm going to temporarily comment out that belongs to contract annotation again, just so that it doesn't interfere with any of the tests and things will compile. And then everybody following along at home or from around the world, wherever you are, let's move into the state tests. And let's just uncomment them all. Let's go big or go home. We're assuming that we got all these functionalities here. So what's going on here? It looks like I have a little dependency issue on my own side. Give me like 2 seconds to sort this out. If you guys are having problems, post in the channel there. Oh, I might be having the same problem that everybody else is having. Like everybody's basically had to download this build. And I think our repo was not updated, but it looks like Peter has updated it. So I'm going to zoom and download again really, really quickly the fix here with a dependency. So everybody just post your comments, your questions while I'm doing this. Think of questions that you might be confused by while we're doing this. Okay, posting in the fix right now. I love it. This is getting exciting. There's no such webinar like a dramatic webinar. I love when things go wrong. But don't worry about it. We're on track. There's never any concern or problem with this. Just doing a quick fix here. Reload. All right, we're in business. Back on track. Everything is gravy train. So, like I said, these tests will basically check certain components. Oh, if anybody had the same problem I had, it's basically, let me go back 1 second. Put in this one line into the build.gradle under the repositories little block there. I'll post this in the general chat. It'll be put it in the bootcamp chat, and I'll also put it in the global WebEx chat. Only if you're having issues or having those squigglies. Now, the first thing that we needed for any state was a way to construct it. So if you look at this first test here, what it was asking for is, hey, build a constructor. Remember, we have that. Second test is saying, like, we need a way to access these properties. So give us those getters and setters. Third test was we need to implement that contract state. Remember that interface at the top that tells Corda this is a valid, this is a contract state. And then third, add 2 participants. So we've done all these. And if luck should have it, if we run this, all of our tests should pass. So if everybody out there is getting 4 tests pass, please put a big thumbs up or a cheer. Yes, we've mastered the state. Awesome. So the next thing that we're going to talk about, we've completed states. We have a working state that's going to represent our tokens that we want to issue. The next thing that we want to do after this is talk about the contract. And remember, up here, this annotation belongs to contract is tying this particular state that we just created to this contract. So this contract is going to follow it along. And this is the thing that we're going to work on next, is we're going to build up this contract. Cannot resolve immutable lists. Somebody's having a problem. Remember, as this goes along, if anybody has problems, just post in. So immutable list, if you need it, it's there. You can import that, but don't worry about that. If you want to create it any other way that you want, you can do arrays.asList. It's another good way to do this. So remember, this is just regular Java. So anything that you would intuitively or regularly be doing with Java, you can, for the most part, leverage that functionality and do things in your CorDapp, basically. So we've covered what belongs to contract does, how it ties the state to the contract. Let's all open up the token contract class here. So everybody is right here. I'm going to take a quick stretch. Everybody stretch your legs because this is a really interesting topic. Token contracts. This is going to guide the creation, modification, destruction of anything that we want to do with that state that we just created. So much the same way that our token state implemented the contract state interface, and that's how Corda knew that it was a contract state. We are going to implement another interface, but this time we're implementing the contract interface. So you'll get this red squiggly line again. And the red squiggly line is basically going to be complaining the same sort of like thing that the contract state was complaining, which is that we didn't override or implement something in that class, something in that interface that needs to be there. So if I go into the contract, we'll see the code, and you'll see that there's one thing here. There's just one thing, and that's a verify method that's going to throw an illegal argument exception. So when we start building in constraints and we're asking for basically conforming to our checklist, we're saying like, okay, this input state, this output state, does it match this rule? Does it match this rule? Does it match this rule? That'll go through the verify, and I'll explain how this works. In the meantime, are there any more questions? I see like, I'm trying to see if other people are having issues. Yeah, Peter will be addressing those issues in the Slack channel, getting you to try different things out. Also, if you're in the online IDE, then Chris has really detailed information about how we can address issues there. So keep posting your problems and your feedback as we go. So going back to the contract, I'm going to implement those methods, and it's going to ask me to implement the verify. So let's talk about what's here right now. There's not too much here, but what we have is actually a valid contract. At the top, on the class signature, we've implemented the contract interface. That has given us this verify method. Just above the verify method, you'll see that there's something called an ID. So we have a property called ID. This is actually allowing us to tie this particular contract to a package. So this is just the idea of like, where is this contract located in terms of like, once our program is compiled and it's in a jar, where's the contract? This becomes useful because you could have different CorDapps across different packages. You might have the same contract name, and this is kind of a way to sift it out to make sure that you're using the correct contract for things like testing, etc. But again, like the contract bytecode will be attached to the particular state that you're working with. So that's what the ID is for. We've got the verify, and then underneath we have commands. So this will take a little bit of unpacking, but I want to talk about commands for a second. When we are building transactions later in the flows, we are going to have different ways that we want to change a particular state. Like when we have our token state, let's go back to the class quickly. When we have our token state that has our properties issuer, owner, and amount, what are the ways that we might want to basically create, modify, or destroy this particular state? If we were creating it, then we would say that could be something like an issuance or bringing something on ledger, however you want to name it. But basically, the checks or the things that we would kind of need to be enforced on a create or an issuance might be slightly different or might be completely different than, say, a transfer, like sending the token to someone else. So commands, what they do is they hint at the intent. The command will hint at the intent of our specific evolution of that state. So what we're trying to do. And how this becomes useful is that we can create individual code for verifying a state based on what we're doing with it. So right now, if you look in this commands interface, we've got one class, which is an issue. So that's saying that we have an issue command. We could add additional ones, such as transfer implements commands. We could add something like lost implements commands. So if I put in these different commands, now I have 3 commands. This is saying that sometimes I want to issue a token, sometimes I want to transfer a token, and sometimes I just lost a token. Hey, I lose my wallet all the time, right? So if these are the cases, we might have different ways or different business logic or rules for verifying like the transaction based on what it's doing. When you are running a contract, so you don't have to do this manually. Your Corda node, when it receives a transaction, will automatically execute this contract. But there's also a way to manually do it when you're building it, when you're building your transaction. I'll show you how to do that. But whenever this thing is run, Corda will instantiate an instance of this contract, and then we'll run the verify. Okay. Give me 1 second here. I'm just dealing with a really important question. Running tests on ide.corda.net. Ooh, I apologize to everybody for not showing this. So I'm going to take like a 1-minute segue to show people how to run tests on the ide.corda.net because it's slightly different. So unfortunately, there's a little bit of a bug right now with the JUnit runner in browser. So I'm going to give you a special command that's going to allow you to follow along and run your tests. So for everybody else, bear with me for 1 moment while I show everybody else what to do. In the meantime, you can basically give high fives to your friends, or you can tell people to start joining the channel and follow along. Tell them to jump on ide.corda.net right now because I'm about to share this screen and play with it a little bit just to show you how to run tests, and then I'll jump back to the contract. Okay, everybody's here. Now we can see that I have just launched up the ide.corda.net. I've got all the same files, and we had those tests that we talked about earlier. They're all blanked out here. The way to run this on the online IDE, let me blow this up so everybody can see. So what I need you guys to do here is actually launch a terminal. So see at the bottom there where it says terminal. Just go to terminal. I'm going to give you a command. Actually, Peter's just posted it in the Slack there. But for those that don't see it, if you put in this command, let me blow this up so you guys can see. Put in /gradle w clean test and then basically the package name. So once you have this command in, you can always use it. The only thing you have to change is this last prefix here. So see where it says bootcamp.statetest? That means I'm running the state test. If I change that to bootcamp.contract test, then I'll run the contract test. Now it actually failed here. It says no test found for given includes, but that's because basically I didn't uncomment these tests and I haven't actually built out this state. But for those that were following along and built out their states, if you uncomment everything in that test or uncomment everything, and then run that terminal command, the one that I just posted, or the one that Peter also put in the Slack channel, this will execute your test. Now, if I wanted to do the contract test, which we're going to be doing next, right? Just change that last part here. So, whoops, I'm hitting all the wrong keys. Sorry about that. Let's go back. So go back to where you had state tests and change this last portion to contract tests. And then the same will go for flow tests. So this is a way to run all of the tests that are uncommented in the ide.corda.net Visual Studio Code. So that's all we needed for that. I hope if anybody's still having problems, just like reach out in the Slack again. In the meantime, let's hop back to the IntelliJ. So like I said, going back to saying that, okay, this is our contract. It's going to jump automatically and execute what's in the verify method. You'll see that the verified method has one and only one parameter. Like it's only taking one argument in, which is of type ledger transaction. What's really cool about this and the way that it works is that when your node executes this contract and jumps into verify, it's going to pass in the transaction associated that this state is associated with as a ledger transaction object. And it's going to say, you can do anything with this particular object. So I can do anything. I have access to all these properties. And I can use any of these properties to create constraints or make my contract do something. But it has to be basically only based on this particular ledger transaction object. And the reason being is that this is basically a distributed technology, right? Like we have different actors, we have different nodes, could be across the world, could be across the hall. That node could be up, that node could be down. And no matter when or where this contract is executed, it has to be able to compute the same result. So we need to make sure that every party, 4, 5, 100 parties are running basically verification on a particular transaction and a set of states, that every state or every input of that transaction, output of that transaction that is being verified comes up with the same result. So if it's a yes for me, if my checklist crosses, it better cross for you. And that's how we do that, by saying that you can't introduce artifacts. You can't pull outside information to create constraints. You have to use what's actually encapsulated in the transaction. So you can play with this. Just have this like tooltips going that'll basically give you suggestions of properties, or you can go right into the ledger transaction on your own time and see what's available to use. Now I'm going to show you what in almost all cases you're going to be able to utilize or use, or you're going to need to use to do basically contract validations. So when I am wanting to verify whether a state transition is legal or not, there's a few things that I'm looking at, and they fall into a few broad categories. Those categories are shape, content, and required signatures. Shape, content, and required signatures. Yes. So what do I mean by that? What I mean by shape is basically like, what are the inputs? What are the outputs? So if it's something like an issuance, something that's going on ledger, I'm creating out of nothing, or like I basically have a real world object or a real world asset, and I'm putting it on ledger, I'm making a record of it. Well, it doesn't exist yet. So that would be sort of like a creation or an issuance, and that transaction would have no inputs. I'm not changing anything. I'm not like taking in an input state and creating an output state. I'm actually just making a transaction that's creating an output state. So if it was a transfer, then the shape would be like, okay, I have an asset, I have something, I have a token, I have a car, and I'm changing like the owner, then I do have an input. So in that case, I would have like maybe one or more inputs, at least one. And then for outputs, I would have at least one, maybe more. Like if it's a token and I have an amount of 100 and I'm giving away one, I would have one input state with amount 100, and I could have two output states with one amount, one of them with one amount being the new owner, and the other one with like 99, which is the previous owner. So that's kind of like shape. Content would be something like, okay, what are the constraints on the actual properties? Like, does the value have to be a certain amount, or does that, does the previous owner have to be the same on the new state? Like maybe nobody can ever transfer their tokens. You can only keep it to yourself, but there's like a magic rainbow or something where you can kind of grab more value. So I could change the amount of my token, but I couldn't change the owner. So that would be sort of like content. The owner has to be the same, or maybe like the amount has to be greater than negative or greater than zero, et cetera, et cetera. So that's content. And then required signers is like who needs to approve or authorize this transition. These are people that might be like, a buyer and a seller. So if I'm selling a product to somebody else, not only do I have to agree to give the product, but the counterparty has to agree to maybe receive the product, or the counterparty has to agree to transfer another state to me, right? So that would be like a two-state transaction. And those required signers were able to check through the contract. So if all these different parties don't agree, then we would kibosh. We would like destroy this transaction and say like, no, this can't move forward. And the way that we kind of like upset or we reject a particular state evolution through the contract is by throwing an illegal argument exception. So everything that we're going to do in here is going to be basically an if statement, pretty much. Like if this, like if it's not doing this, throw a legal argument exception. If this state is not, like if our token doesn't have a value above 0, throw an illegal argument exception. So we're just going to build these things out. But let's get going here, and I'm going to set things up and show you how you'll be able to quickly set things up on your own contracts as well. So when you're done this, you'll be able to build your own. So the first thing that I want to do that's useful when dealing with shape, remember, is I can pull out all the inputs in this transaction. Like what are all the inputs that were defined in the transaction? And the way I can do this is by grabbing the inputs from that transaction, ledger transaction. So over here, I typed in TX and dot, and I got a list. Start typing in get inputs, and then grab get input states. So now you'll see that the variable that I assigned is red, and the reason is because I haven't created a type for it. But if you highlight over it and you autocorrect and create local variable inputs, you'll be able to automatically, your IDE will automatically choose the correct type. So it's a list of contract states. Remember that our token state is derived from the interface, is derived from contract state. So it essentially is a contract state. Let's grab the outputs. Get output states. Do the same thing. Instantiate this local variable. And then the other thing that we want to grab is the commands. Remember we talked about the commands? So this particular contract has 3 different types of commands that we can instantiate. And when a transaction is built, one of those commands will be inserted into the transaction along with this particular, like to reference this particular state. And it's going to hint the intent. So we'll put commands equals tx dot get commands. Boom. And I got all the commands. Now, one thing to point out is that you'll notice that this commands that I pulled out, it's not just the regular commands that are here. See, we have issue implements commands, transfer implements commands, lost implements commands. The one that we received back was a list of commands with parties. Well, what's commands with parties? Let's click on it and just look, and you'll see that commands with parties, I apologize that this is actually Kotlin, but I'll intuitively show you what's going on here. Commands with parties is just a wrapper. And all it does is associate the command, and the command is actually stored in this value property. So it associates the actual command with a list of signers. So when we are talking about required signers, etc., we're going to tie the required signers to the command when we build the transaction. And when we grab that transaction in our contract, it's going to be wrapped in like a bundle. So it's going to say, here are the list of commands, and each of these commands requires these signers. So those are the things that we're basically most of the time going to be able to use to create our constraints. Now, I want to start making things up. I want to start making up business rules related to our token state, related to on what we can do, like what's an issuance. And the way that I'm going to do that is, like I said, with basic if statements. So I can say if the inputs dot size not equal to 0, then if inputs dot size not equal to 0, then throw new illegal argument exception, which is basically, remember, what we wanted to do whenever a constraint fails. And I'll say here that an issuance, or like a particular, like what we're trying to define here, is that the inputs have to be 0. And when it got to this point here, and it saw that this transaction had more than 0 inputs, like if it was not conforming, then it's going to throw the exception. So I'm going to make a couple modifications here. One of them is that I want to show you how to branch. So this would assume, like if I go around this route and I start planning all my constraints for an issuance, this would assume that the only thing I'm verifying is an issue. But remember, we could do many other things. So I want to show you how to add additional constraints. And basically, you can just branch off it. So if I took one of those commands, I could check what type of command it is, instance of, and then I could basically branch and say that if it's an issue, do A, do B, etc., etc. And then I could have put this inside. So I'm showing you the most minimal and sort of like the simplest syntax for how to start branching and building constraints. And then I would put another constraint here. But because we're all together, and there's still like a bunch of us, like, oh, wow, we still have a lot of people. And I'm so happy that everybody's here. Because we're doing this together, I'm going to show you something really useful that's going to take this to the next level. So instead of just doing if, etc., and instead of doing things like, checking like what is like a particular command, is it this type, is it that type, there's something called a contracts DSL, which is a domain specific language, which is basically a tool that you can use on your contracts. And I'm going to import this, I'm going to import it, and then I'm going to post this import statement into the chat so you guys can import it as well, and we can work with this. So I'm going to import static net.corda core contracts DSL star. And this line is going to give us 2 tools, which are going to really help us, really help us build this contract out. So I'll post it in here. So put this import in, post it in here. So what this gives us is I'm going to comment out this commands quickly, and I'm going to put in something else. I'm going to put command equals require single command. And what this is doing, I'll tell you what this little this little tool does here. This is going to enforce 2 things. It's number 1, it's going to take in all the commands tied to this transaction, and I'm going to be able to pass in as a second argument a class of a type of command. And this is going to enforce that, number 1, the command that it returns is of the type that I'm looking for, that I'm kind of wanting, that I passed in as a second argument. And then number two, it's going to check that there's only one of those. Because think about it, does it make sense to simultaneously modify a state in two different ways in the same transaction? So you would not want to do that. And actually, in the test, one of the things that this contract, our tests on this contract will check is that we only have one command of a particular type, and that our command is of a particular type. So to use this, we throw in the commands that come from the transactions. And here, I could either pass in like one of these on its own, or I can pass in sort of an abstraction. I can say that basically any command, any one of these is okay as long as there's just one. So this is a paradigm that you're going to be wanting to use over and over again when you build your contracts, which is why I wanted to throw in this require single command and show you guys how to use it. So let's do commands dot class. So now I'm saying, as long as the command in this transaction is one of these valid commands, and as long as there's only one, then we're all good. And I'll get a single command. And then from here, this is where I could sort of do that branch again. So now I could do if command.getValue instance of commands.issue, else if command.getValue instance of commands.transfer. And then finally, I could do go for lost. So or if it's lost. So these are different things. I'll just do else. So now I have three different branches, and only the ones conforming to the particular transaction would be executed. So let's build out the full issue. The second tool that I'm offering you guys that's awesome is, remember I was doing those if statements. I was saying like, if not this, then throw a legal argument exception. If not this, throw a legal argument exception. But we have in the DSL require that, which is a much, much nicer syntactic sugar, I guess, and really efficient for building out your requirements. So required that, it's going to take in a function. It's going to take in a lambda. This is how you build it up. So everybody just copy this here. So let's set this up. Be careful with those different like curly braces and the open closing parentheses. Return null at the end. So this is basically the setup here. I want everybody to get to this point. This is going to allow us to build up. Is everybody feeling comfortable so far with what's going on in terms of using the contracts DSL, what we're trying to achieve, the fact that we can only use the ledger transaction so that it's deterministic, and also how we're branching? Is everybody cool with this? Like, are there any questions? Okay, awesome. I think we're good. We're good. We're good. So somebody said it's not resolving. The DSL is not resolving. I'd say like number one, check that your import is static. And you have this one, basically the one that I posted. If it's still not working, you're totally fine using if statements. So you can follow along instead of using these different DSL tools, just use if statements. Also, if you get totally stuck, there is a solutions.md. So if you're kind of like stuck on a particular like syntax position or whatnot, go to solutions.md in the repo, and then you'll be able to kind of like do like a little quick cheat there. But let's build this out. So remember, I talked about shape. I talked about content, and I talked about required signers, required signatures. Now, since we're on the flow, we're ready to build, I'm going to amp things up a bit and give some energy to this. This is going to be super good. Let's hammer this out as quickly as possible, but with time to follow. So I'm going to explain things as I type. If we grab that parameter, like see in our little, like we have required. You can name this anything you want, but I called it rec. Rec.using. So using is going to allow us to bake in a condition as well as a string notifying us or telling us what that condition is checking. And if this condition doesn't hold, if this Boolean expression doesn't hold, rec will automatically throw an illegal argument exception. So with shape, we're doing an issuance here. Remember, we're issuing. So what we need is for our issuance to have 0 inputs. Inputs must be 0. And then I can grab those inputs. Dot size equals 0. If this doesn't happen, the transaction will kibosh. It will not go through. Second, we need our outputs to be 1. So with an issuance, we're creating something. We're putting an instantiation on ledger. So our outputs have to have something. So we're going to make outputs.size has to equal 1. Next, what are we checking? So if the inputs must be 0, the outputs must be 1. We also need to make sure, let's make sure that it's the right state, right? So remember, we took in this list of contract states because a transaction can be a transaction on any sort of asset, any sort of shared fact. It doesn't have to be a token. So ledger transaction returns it as contract states. Let's make sure that that output is of type contract state. Sorry, token state, the one that we're looking for. Now, what's interesting here is that because this is sequential, because every constraint is being checked one by one, every single check that we pass, we can rely on. We can say this is guaranteed to be true from now on. So we know that there's only one output. And because we know there's only one output, we can grab the first output and check the instance of that. Instance of token state. And now we have this sort of shape. We're saying like, okay, now we know what's coming in. Now we know what's going out. Let's check the content. Let's see what's inside. Because we have just passed this constraint, the one saying that this is definitely, the output state is definitely a token state. Now we can actually grab that state. We can actually cast it. We can grab it to use and dive into those properties with our getter. So I'm going to say token state equals outputs.get 0. And now it's going to ask me, oh, you didn't cast it, so let's cast. Now that I have a token state to work with, I can actually start checking what's inside of it. So let's go back to a requirement. We're going to say like require that the value or like the amount of this token state is greater than 0. Because why would we issue a negative amount? It just doesn't make sense. So let's take our token state, and remember we have those getters. We can get the amount. Check that it's greater than 0. So this is the only thing. We're just carrying that the amount is greater than 0. The next thing that we want to check is remember those required signers. Who has to authorize this? We can't just arbitrarily be, like sending out transactions, etc. if we don't have a particular check. And in this case, the person that we really, really want to make sure is cool with this deal is the issuer. Like if the issuer is one that's kind of creating these tokens and assigning them to an owner, well, we want to make sure that the issuer approves. And the reason being is that anybody can propose transactions on the network. So anybody could try to propose a new state. I could create an instance of a token and put in that instance that the issuer was like Wile E. Coyote, even though I'm not Wiley. So I'm like trying to commit some fraud and say that, hey, like here's money from Wiley. But no, that won't go through if we make sure that Wiley has actually signed on that transaction proposal. So the required signers is really important. So we'll put in a condition here that in this particular issuance, the issuer has to be a required signer. So the issuer has to sign. And the way that we can check this is, remember, we grabbed up here the command, which was this wrapper that had not only the command, but also a list of signers. So if I take that command.get signers, and I say, you know, that's just a collection, right? I can say that this get signers contains, and now I can say like it has to contain something. I'll take the token state and grab the issuer and then grab the owning key. So I hope everybody's following along with this. Grab the issuer, grab the owning key. So now this is going to enforce that the issuer's key has to be there and has to be one of the signers for this. So that's pretty much it. Now, I apologize if this might have been sort of like a dry section, but it's really important. And then, does anybody have any questions? We're about to run this. I'm going to go to the test, and I'm going to make sure that the tests all pass and that this is actually a valid contract. Is everybody ready for that, for some test action? Okay, let's do it. Double check. Good, 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 good. And remember, I didn't fill in the transfer or the else, because the test that I'm running and the things that we're building, we're just going to do the issuance today. But later on, you can build this up and do more things with it. So everybody go to contract test. Let's do a bulk on comment. So grab all that commented text. Make sure you don't get the last trailing parentheses though. That can botch things up. See, the commenting ends like right here, and we don't want to go further than that. So command / I got everything exposed. And let's look at some of these tests. We look at the signature, what's going on here. I'm going to bang through them really quick. Number one, token contract implements contract. So remember, Corda knows this is a contract because we implemented the contract interface. The token contract requires 0 inputs. That was our first constraint that we built. The token contract requires 1 output. We did that. Token contract requires 1 command. Remember that contract DSL requires single command, handled that for us. Token contract requires the transaction output be a token state. We checked that. Token contract requires the output to have a positive amount. We checked that. Token contract has to be an issue command. That was in that was twofold. Number one, we require single command, and we did that on the commands interface. So with that, we knew that it was either an issuance, a transfer, or it was either an issuance, a transfer, or a lost. And then we branched into that particular, a little like contract verification code. And then required the signer, the issuer be a signer in the transaction. Now I spotted one little error here, and it's not to do with the code we did. The code we did was completely good. It's purely an artifact of these tests. And I think where it'll fail might be token contract requires a transaction command to be an issue command, because this is a very narrow test. And what this is wanting is that it's wanting to say that these don't exist. It's wanting to say that if it's not an issue command, this whole thing will fail. And our code is not really designed like that right now because we wanted to expand it. I wanted to show you how you could add additional commands. But to just satisfy this one constraint for that little like play test, we have 2 options. I can put in that it has to be issue up here. So I can do that. Let me see what's complaining here. Party commands.issue. So I can modify the require single command to be even more constrained. Or what I could have done just for this test. Now, generally, when you're making contracts, you're going to want to allow more than 1 command because it just makes sense that you have different evolutions. But for this one test, the other thing I can do is kind of put it in here, put it in a requirement. So I'll say that, I'll put it out of here because it's, do it here. let's just put it outside. So I could have put right off the bat that if the command.value is not an instance of commands.issue, then fail. So you could structure this in Java any way you want, but basically, does everybody understand how for this particular test, we have to constrain it a little bit more? So I'll just do that here. I'll just put it in a statement. Instance of commands.issue. But I think the better way to do this would be to do it in the do it with a require single command. It's a lot cleaner. But I just want to show you like many different options. So command must be of type issue. There we go. So kind of like a little botch job, but now we're ready to pass all the tests. Let's run this and cheer if this works. Don't mind those little red lines. That's kind of just like the test framework doing its thing. It's not a big deal. What we want in the end is to be able to pass all these tests. And it looks like we've done it. We've succeeded. So is everybody still with me here? Does anybody have questions? I'm going to open up the stage here, the platform for questions regarding contracts, because this was sort of the meaty part and a very important part about building CorDapps, is building in that business logic to make sure everybody's on board about how we enforce among distrusting parties that transactions will be valid, etc. So why, there's a question. Somebody says, why are you so awesome at this? I have no idea. Like, I have no idea. I think the closest answer would be the fact that I work at R3. So, and I'm not just saying that for like BS, but really the organization here is completely supportive and enthusiastic. And we have a ton of creative people working all the time on amazingly interesting things. So I get excited about it. And when you guys are playing with code and you see how easy it is to build CorDapps, you'll get excited about it within like, I don't know what it is, within a day, within a month. You will also be able to do like basically these things as well. So we'll keep going. Oh, geez, what time is it? So it's almost 3. I'm super sorry that we're going a little bit over time, but I promise you, if you can stick with it, we're going to keep this session open because we're going to go over flows. This is what you need for a CorDapp. We promised that you'd be able to build a CorDapp. So I'm hoping that everybody has that extra 20 minutes, that extra 30 minutes to build this out. If you don't have time and you have to jet for a meeting, etc., it's totally fine. This content will be available online, and you can reach out to us through Slack, or you can basically go through the docs and build this out. Use the template that we have here to keep going. But we're going to keep going after I answer these questions. So a quick question. We verified the issuer signature. Should we also be verifying the receiver's signature for acknowledging the transaction? So my answer to this is that it's completely up to you. So it depends on your use case, and it depends on what you've agreed upon with your counterparties and what kind of CorDapp you're trying to build. Like, for instance, I could look at it either way. If I was a generous person and I was going to be issuing tokens to people, random people across the network, they might not necessarily, have to sign. Like, do you want to put in an extra step if somebody's giving you something? I don't have to. So like where this turns into like a technical discussion, I guess where this is alluding is that if I don't verify if I don't sign it, do I still get it? I guess that's a intuitive question. And the answer is yes. And the reason it's yes is, remember in our state, we put in the participants, issuer and owner. That means that all of these, both the issuer and owner, will get a record. And furthermore, that record will have the properties that were approved, that were signed. And that would have the owner as the receiver. Now, to make this happen, to make it go through, we only require the issuer's signature, but after the issuer signs and that's approved, then basically this transaction will be immutable. It will be on ledger, and the two parties that will know about it are the issuer and the owner. So the owner, like, even though they didn't sign, they still own it, they still have it, and they're still able to use that in subsequent transactions. They're able to spend it, etc. So we're going to talk about flows now, unless anybody else has more questions. So 30 more seconds. Does anybody have a riveting question that I could enlighten anybody about contracts? It's a pretty intuitive concept, I think. I think if you get the sort of like intuition behind it and think of it as a checklist, the rest is sort of just like details and minor implementation things, which we have the code sample for, and you'll be able to play with. But without further ado, we're going to move on to our third component, which is the flow. And remember, now we have the state, now we have the contract. How do we use this state and associated contract in transactions? How do we do things on the network, etc.? This is done through the flow. Now, before I go into that, let me just show you, give you a little sneak peek, a little preview of how these flows will run when we have our basic mock network, etc., when we're actually deploying. So in the build.gradle, we double click this. You're going to see a lot of like dependency stuff, blah, 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 blah. No need to worry about this. But if we go to the bottom, there's a task that's called deploy nodes. And deploy nodes is basically a configuration. It's a task that we're going to be able to configure through this script here to create mock counterparties on a network. So these are going to be counterparties that we define. There's a notary, there's a party A, a party B, a party C. We're going to create this network. When we run this task later, and I'll show you how to do it, it will basically generate persistent file structures on our local machine for each node. And it's going to be able to output a script that's going to allow us in one step to launch all these nodes, to bring them all up, to basically run Corda jars on each of them with our application. And then further to that, it's going to give us an interface to interact with our application so we can run these flows. So that's just alluding to how this is going to work. And now we're going to talk about the flow. So go back to your main package, and then we have framework for two different flows. We've got a token issue flow initiator, and we've got a token issue flow responder. Let's open up the flow initiator first and see what scaffolding is available here. So in the flow initiator, the first thing I'm going to show you is just like how the contract state interface notified Corda that our token state was a contract state, and just how the contract interface hinted to Corda that our contract was an actual valid contract with a genuine verify method that needed to be tied to a state that we tied to our token state. The way that we define a flow in Corda is we extend it from an abstract class. We extend it from flow logic, and the type that we put in here, this is a generic, so we can type this, will be what this particular flow will return when it's called from this call method. So there's a lot here, but just to make things simple and so you understand it, let me eliminate all this mumbo jumbo and go to a blank class really quick. Sample flow. I want you to see what's going on here. And I'll show you like a minimal flow without all that stuff in there. So if I extend, if I create a class and I extend flow logic and say that this particular flow is going to be used to create a transaction, I can put in here just like signed transaction, but it doesn't have to be a signed transaction. This flow could be used for anything. Like I could use a flow to check, query an internal database or check the time on my node or whatnot. So you can put something else in here, like you can put void, like you don't need anything back, or you can put unit if you're in Kotlin. This is sort of like up to you, but let's pretend that this particular flow I want to build a transaction with, just like contract made us override a verify method and implement that. flow logic has one method called call. And you can think of call as like your main method in Java or whatever. Like, you're creating a program, public static void main. This is like the execution entry point. In Corda world, when you execute a flow, think of a flow as like an action. You can think of it as like a script to do something. Or if you're on Windows, it could be like your desktop icon that launches Chrome or launches Explorer. It's an object that allows that when you activate it, it does something. It's going to jump right into the call and start executing that. So that's basically what we need is to create our logic here. So logic, what we want to do. Then with flows, you'll need a constructor. So you need a way to instantiate it, like just to create it. And when you have your constructor, this would take in the properties that you need in order to basically do the whatever you're trying to do. Like if you're trying to build a transaction and I need to assign a token state to somebody, I would need to know, like, when I execute the flow, who's going to be the new owner, who's going to be, like, what the amount's going to be, etc. So I would put it in here in the constructor, and then you can also assign properties, etc. But going from this as like a minimal version of what a flow is, I'll show you also that there's a couple annotations that are needed. So one of them is I can define this as an initiating flow, meaning that I can launch this. I can actually do something with this, like it's an actual action. And then I can put startable by RPC, which is like I'm going to initiate this through an RPC connection, through like a UI or through a shell, et cetera, et cetera. There's other ways that you can kick off flows, which would be through like a Corda service or whatever. So you could do like startable by service, etc. So these are options here. If you have an initiating flow that has any sort of like connection or has interactions across the network, then you would have also an annotation called respond initiated by, like for a responder. So I don't want to confuse things too much, but now that you know like the basic like scaffolding or what would be in a flow, let's go back to the flow initiator, which is set up for you. And I'm going to go piece by piece. What is happening here? So remember, we saw the annotations. So this is an initiating flow. I'm able to kick it off. I'm on my node chilling, and I want to issue some tokens. Whatever way I do that, whether it's through like a REST API, like through a front end, or whether I'm a hacker and I'm going through my terminal to execute this, I'm allowed to. And that's going to be startable by RPC. So we're going to be interacting through the crash shell. So when we launch our nodes, we'll get a shell interface, which actually in the backend behind that interface, it's launching an RPC connection to the node. So to send commands in and out and interact with a node, you are using RPC. For nodes to talk to each other, they're using AMQP and over a TLS connection. But for interfacing and launching things, kicking things off, we're using RPC. So extending flow logic, we know this is a flow. It's going to basically deal with a signed transaction and return that from the call method. First thing it's going to do, it's going to instantiate. Corda will create an instance of this with the parameters you passed in. When we instantiate this, we're going to pass it an owner and amount. So we're going to know who we want to issue this to, and we're going to know how much we want that token to be worth. It's going to store those in its properties, and then boom, go to the call method. It's going to kick off and go right into the call method. When it's in the call method, we're able to do whatever we want to do. We're able to do our things. Now, you'll notice that there's a progress tracker here. Don't worry about it for the course of this bootcamp, but basically this is an element that you can instantiate to track or do progress checks, like checkpoints during your flow. You'll see that when we launch these in the shell, that it's going to give us little status like, oh, transaction has been verified, transaction is waiting for collecting signatures, et cetera, et cetera. So these are things you can define with progress tracker, but it's just an option. It's just optional. We don't need it for sure. We only took in the owner and the amount. So that brings up the question, like, who's the issuer? And we can make assumptions, or the way that we want to design it is up to us. but we're making the assumption that whichever party initiates this flow, whichever kicks it off, is going to be the issuer. So whoever does this, whoever runs this will be the issuer, and they'll be able to define who they're sending the token to and the amount. Now, when I said that flows allow us to do things easily through Corda, I wasn't lying. And the way that it does this is we have this API. So a lot of the DLT properties and the things that we need to do, key management, messaging services, etc., are abstracted away from the programmer. I don't need to specifically open up like a TLS connection or like, program certain parameters, etc. We make it a lot more high level, but we offer all the functionality through an API, like what we call a service hub. And a service hub is basically the interface to the underlying node properties, so the things that we can do on with DLT through our node. So the first thing we did here is we used that service hub. We said, okay, let's go into our node. Let's get the network map cache. And what we want to do is grab a notary. So any transaction we build, remember that notary has to check uniqueness. So we need to attach a notary, like we need to have a notary assigned for a transaction. So what this line is doing here is going through that address book, the network map cache. Remember I said everybody has a copy of the address book, knowing where all the other parties reside on the network. And it's grabbing all of the notaries on this network. And then it's getting the first one. Now, this is really good for the sample, but this is really bad practice for production and like in the real world. So what you don't want to do is just grab a random notary, because the network could have multiple notaries, and you want to make sure that you're specifically utilizing the correct one, the one that you want. So there's other ways to grab a notary besides just grabbing all of them, getting the first one. You can get them by Corda X500 name, etc. So every single actor on a network has that X500 name. Remember in the build.gradle, we assigned names here. See these names? So these would be like basically properties of an X500 name. So you're able to take identities and things like this and then derive or grab the notary you want. For our own purposes here, just to be really quick and succinct, let's do basically grabbing all of them and then taking the first one. So it's super cool. Apologies again for going overtime. I hope you guys are still having fun. It's going to get better, trust me. So we have a notary now for our transaction. Let's go on to the next slide. Remember I said that whoever pops this off is going to be the issuer. So we have a function here that's going to return our party, the node that we're on. So whatever node we're on, if we get our identity, we get our identity. Like this is like free IDs, which is awesome. We can get some beer with these IDs. Yeah, so we're the issuer. And then look at these like blue like to-dos here. This is what we're going to do to build a transaction. We're going to instantiate a state, an output state, what we're trying to include in the transaction. If this was a transaction such as a transfer and we also had an input state, we would grab that state reference, or we would create a variable here that would store the input state as well. So this is where you start collecting, like collect all your stuff, collect goodies up in here. So everything that we need for this transaction. Then after that, we're going to instantiate something called a transaction builder. And transaction builder is a tool that is going to allow us to easily, like super easily, add inputs, add outputs, add commands with attached signers, etc., to create a full transaction. Is everybody following here? Yes. And then once we have a transaction built, this is what's going to happen. We're going to verify, which means that on our node, before we send this out, we're going to check the transaction using our own contract, like the contract that was created. So the bytecode that's attached to this token state, contract attached to this token state, is going to be run to make sure that we created a good output state, that this transaction that we built is valid, because it's perfectly legal to build a bad transaction. But what you want to make sure is that your contract catches it, that your contract kills that transaction. So that's what's happening here, is that we're making sure that this is good. Then flow session. So this is a special object. A flow session is basically an instantiation of a channel of a network tunnel, like a point-to-point communication route to whoever we put in this argument here. So we're saying that we want to send this token to the owner. So we need a way to get there. We already have the owner, like the party, we have the object party that got passed in through the parameter of the flow itself, but we need a way to, like, now that we have that particular entity, we need a way to connect. And we do that by a flow session. So a flow session is like making that channel. Then here in this line here, we're gonna sign it. We're gonna take our transaction, put our key on it, the issuer key. And then below that, we're gonna collect signatures. We're gonna go through that flow session, and then we're gonna collect those signatures from the counterparty, and we're gonna bring it back to a fully signed transaction. So this is a subflow. Remember, you can run flows and flows, so you can keep reusing code. Then finally, at the end, we're going to run what's called a finality flow. And the finality flow is going to take that fully signed transaction, pass it to the notary to check for uniqueness, to make sure that we're not double spending or invalidating in any way. And then after we get that notary sign off, it's going to come back to us. It's going to be written to our ledger, and then it's going to be written to the owner's ledger as well. And at that point, when there's finality, we know that we both have the same record and we both agreed already. And, you know, Bob's your uncle, the transaction went through. So this is going to go pretty quickly. After I code this all, I'm going to ask if you guys have questions. If you don't have questions, we're going to launch it, and we're going to basically see it in action, and then party on. So here we go. I'm going to build a token state using the class that we created earlier. New token state. And the token state takes in an issuer, takes in an owner, and an amount. Next, I could jump right to here, but I need one more thing. So every transaction has at least one or more inputs or output states, and a transaction has to have a command. So remember, the command was something that tied in the intent and also the required signatures. So I'm going to create a command here. So I'm going to do issue command. So I'll create an instance of command, which I'll grab from the token contract. New command. Token contract. So let's go command. Oh, I didn't want token contract command. I just wanted command. Sorry, there's multiple ways to do this. So I have the instance of the command that I want, which is going to be issue. And then the required signers. So remember, the required signer was the issuer of this token state. So now I have a command and I'm ready to go. I have the things that I need. Let's instantiate this transaction builder. Just bear with me, people. We're almost to the flow. It's going to be awesome. Pass in a notary. And then the builder, basically, I can build on top of this using builder paradigm. Hope everybody's getting this. It's going quickly. So I want to add stuff to this transaction. And I'm going to add an output state, which is the one that I just made. And I'm going to add also, just as like a little coolness factor here. Remember, I was talking about that ID in the contract. Well, I'm going to add that ID to make sure that this transaction knows which package this particular contract resides in. And then I'm also going to add a command. So I hope you guys are typing along at home. Let's add in the command, the issue command. Boom. So now I've got an output state and I've got a command in the transaction builder there, and then everything else will basically kick off from there. So this is all we needed. Let's go to the tests and make sure those run. Go to flow tests, uncomment everything here. This will take a little bit longer for you to run on your computer, just because these tests tend to be a bit slower. But if everything goes well, this is checking things like that. You use the correct notary, that you had that first notary in there. It has that the transaction has one token state output. Basically, it's reconfirming some of the things in the contract, but just on like simple test cases. So you can play with these and play with tests on your own time, but this is a completely valid flow. And if we pass everything, then we're going to be able to use this in actual mock production, so on our mock network. We got 2 tests. We got 3 tests. 4. Something failed. Oh, something failed. Abort mission. Hold on. Let me grab what's going on here. So the crunch time is on because I was trying to finish this up quick for you guys, but it looks like I had a little single point of failure. Tried to access an empty buffer. Fails not equals one command with issuer and the owner. Oh, okay. So this particular flow wanted the owner as well. So what we just do here is when we built the command, let's put in the owner also. Now, this is really confusing. So I want to point one thing out, and I think we should fix this later. I think this should be fixed later. But our contract, ourselves that we built earlier, we didn't actually define that the owner had to sign. So that wasn't a requirement. But the fact that it's crashing now was actually just because of the test. So the test that was programmed is requiring both in the command. But our contract, our business logic actually wasn't. So that's what went on there. That's why I kind of got confused for a second. So let's run this again. While this is going, does anybody have any questions? Like, fire them off. Is anything completely confusing? Or does it sort of make sense at this point? How we built the transaction, how we're able to basically verify and send that transaction across the network, collect signatures, and then basically run a finality flow, which will resolve and then write this transaction, if it's approved, to the parties. Belongs to contract. Make sure you uncomment that. Which code are you looking for? The flow issuance. Okay. Okay, so here's the code. I'll run this one more time because I didn't uncomment the belongs to, apparently. I apologize for going overtime. I hope you guys are still enjoying this, and I hope it's not a strain on your time. I just basically have one more thing to show you, which is actually how to make it run and make it go, and how to play with the crash shell and be able to interact when you're developing. And then I'll be here to field questions, etc. What is failing on this flow? Okay, now's the time to keep recording because I'm having technical things and this will get really funny. Public no transactions doesn't exist. Okay, I'm gonna give you a quick little debug sesh because I need to do this to make it work. If you got a jet, I won't be offended at all, but I'm hoping you stick with us because I just want to sort this out. I hate having technical difficulties during a thing. I obviously, because this is my first webinar, I must have missed something. I'll correct it right away. I apologize for the time delay here, and I apologize if this is confusing you guys in any way. But trust me, it's my error, it's not yours. But how I can do is basically the original concept of the test-driven development is if we go through these tests one by one and make sure that something that we did basically that every component passed. So this is really odd because I passed all these tests before, and now on this one test, it's not passing. That's really weird. Let me just clean this quickly. It was going so well till the technical difficulties. Gran is very disappointed in me right now. Okay, so I just cleaned. Let's run it again. Make sure this works. Is it missing get owning key on the command? Oh, well, we're not doing that check yet. This is just checking for the notary. So as long as it has this notary, it should be fine. I think something must have gone wrong on the build perhaps or something. Give me a second here. Let's make sure. Okay, I must have botched something up. Let me go back. So we got the command issue. It's what's going on here? Oh, dude, you caught my mistake, I think. Badass. Nice, nice. I think I just swore on here. Thanks for catching that. You're my hero. Who was that? Who was that? That you are totally my hero. I saw somebody that was like, "Oh yeah, you missed the keys itself." Thanks. Yeah, it was Joseph. You rock, dude. This is like why the live code is such a thing, right? But I always like doing live codes. Oh yes, there it is. Okay, let's go. Let's go. Let's go. Let's go. Counters on. Let's do them all together. Let's hit them all off at once. And then I promise you we'll move on. I can't believe like we're overtime and so many of you are still here. Props out. Like we really didn't lose too many people. This is amazing. I love you all. Mwah, mwah. So this is a basic flow. We didn't have questions about it. I just want to make sure this passes because if it doesn't pass, then we won't be able to play with it in the shell. But once this all passes and we're good to go, we can kick off an actual deployment based on that build.gradle I showed you earlier. So far, so good. I noticed that if we get past 4, we're always good. Yeah, we're good. Oh yeah, total feeling of joy. So Renee was like that feeling of joy after fixing the fails. More like that feeling of keeping your job, something like that. So yeah, I'm really happy right now. Thanks everybody. So now let's go back to the terminal. Can everybody see my terminal? Remember that task I showed you earlier? I'll post this in the channel how to run it, but do /gradle w deploy nodes. This is going to kick off that task that we configured that has the different nodes and is going to run that mock network. Oh, not run it yet, but basically build the persistent file structure and have it available for us to kick off and launch. So I see some of you, somebody said they're enjoying this. Like, I'm really appreciative. Any good feedback is amazing and it really motivates me, like energizes me. Kick off that deploy nodes, watch the magic happen in the background. Bing, 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 bing. So while this is creating like a mock network on our local machine, it's also compiling that project and that app that we just created. Um, and it's like going to install it. So it's going to install that app on the nodes, on the party A, the party B, the party C. And it's going to kick off 3 nodes plus a notary. And then we're going to be able to actually interact with these nodes and run that flow from our choice. So we can pretend to be party A, we can pretend to be party B or party C. And then we'll be able to send tokens to an owner. The best thing in the world, give away free money. So now that we're here, we have build successful. I'll show you how to launch this. Put in build nodes, run nodes, build nodes, run nodes. If you're on Windows, it's a little bit different, right? But like you can basically reverse the slashes and stuff and run nodes.bat.batch file. But this script will take those nodes that we just generated and launch terminal instances for each one. So boom, stuff is happening. So you'll notice on my terminal, these windows have started popping up. I got 4 additional windows that show like gibberish. It's not really gibberish. It's sort of like, you know, like just executing these particular bash commands. But now you see this Corda. Don't forget to read the jokes. Regular naps prevent old age, especially if you take them whilst driving. And not so good of an idea. But from here, just give it a little bit of time. Check that your other ones are also launching. And then once it's all loaded, you're going to get a terminal prompt. So there's some information here. Let me show you what's going on. I've got some ports. That means that this particular node instance has these ports open. Remember, we're kicking off flows. We're interacting through RPC connection. So it's connected on this address locally. I've got that this is party B. That's who I am. This guy's party B. This window here, I don't know if you saw that. I just switched windows. This is party C. And then we also have party A and a notary. Simple enough. Now, let me get to it. Let me show you some basic node interactions. The first one that you could try is flow list. So type in, let me boost this up for you. Type in flow list and press enter. You're going to get a list of all the flows available on this node. This means it goes through all of the CorDapp jars that are installed on this node. Remember, the bootcamp was installed, and this example's art transfer flow was actually that sample. There's another directory with a fully formed project of an art token. So the nodes were also installed with that because it was part of the project. The one that we created is the token issue flow initiator. And we're going to have this app on all the nodes. The next command that I want to show you is run vault query contract state type. This is really quick. I'm going to post this for you. Don't worry. Contract state type net.contracts. net.corda.core.contracts.contract state. So this is just a basic query command that is a catch-all for anything on this particular node's ledger. So remember, any state that we created inherited or implemented the contract state interface. So if I execute this, it basically shows that this node has nothing, has no knowledge of the world, it has no states. So I'll put this in the chats for you guys so you can paste it into your shell. The big finale is coming up. So we have a way to query the vault. We queried party B. Let's query like party C. Oh, I missed an E. Sorry guys, I missed an E on that last command I posted you. So I'll just add it here. Just add that E. So party C has nothing. And then party A. Where's party A? Party A, my friend, where are you? Party A, okay. Party A has nothing. So that means everybody's starting from scratch. I'm on party A now, and let's just launch this flow. So you can do flow start. And then remember from flow list, it showed what we had. The shell is pretty smart in the sense that if I flow start something unique, like token issue, I don't have to put in the full package, fully qualified package name. Like I can just put in sort of like the beginning of it. And when I launch this, it's going to say like, I can't run this because I'm missing the pertinent information. I'm missing the things I need to construct this. So all we need to do is put in a party and an amount, and this will instantiate an instance of that flow initiator, pass in that party amount as arguments, and then build that whole transaction and kick it off and send it. So what I'll do now is I'm feeling generous to party B. Let's send party B some money. Flow start issue, token issue. Then this is how you put in the parameters. Put in owner, space, put in your party B, and then put in your amount. Let's be super, super generous because this guy had to wait so long. Party B wanted to get his shell up and running and have free tokens a long time ago, but because I botched up the tests, it took a little bit longer. So to make him feel better, I'm going to give him 200,000, whatever it is, probably pounds, or maybe euros because the pounds might go down. And when I run this, it's going to run our CorDapp. Starting, collecting signatures from counterparties, verifying broadcasting transaction to participants, flow completed. So now that this transaction has gone through, if we query the vault now, we see a record of that state. This is our state here, our token state. We're the issuer, the owner is party B, and the amount was 200,000. This here is a reference to this particular state. It has the transaction hash and the index. So remember I was saying the notary will check all future transactions, check every transaction to make sure that any states that are being consumed have not been consumed before. This is that string ID. It takes basically this. If this transaction had multiple states, so then you would have basically transaction hash index 0, transaction hash index 1, et cetera, et cetera. Now, the really cool thing about this that's going to blow your mind is that if we go to party B now, the one that we sent the tokens to, and run the same query, they also have a copy of this state, exact replica, exact identical, immutable ledger entry that we have saying that they have 200,000. But the thing is, if we go to party C, who was not involved, who is not the issuer, who is not the owner, this guy is what we call irrelevant. He's not relevant to this transaction. He's not part of the need to know. Then he has nothing. Yes. Did I just explode some minds? So that's basically what it is. I'm going to open up the floor for any questions on flows and then any general questions. I'm really sorry I went overtime, but I hope you guys kind of got a sense of it. Let's go back to the code. While I'm answering questions, you guys can play around with your shell, issue different tokens, party A to party C, party B to party A, see what happens. Do I have any questions? Are any takers? Launch your questions regarding flows or regarding states or regarding contracts or regarding, will the online IDE be available for some more time for us to try? Yes, the online IDE is available 24/7. Not only is it available 24/7, but it's persistent. So you notice that when you typed in ide.corda.net and entered that URL, it actually assigned a prefix to that URL, which is a unique identifier for your instantiation of that Docker instance. So if you remember that URL or bookmark it, etc., you can come back the day after or like a week later and keep working exactly where you left off. So you can delete everything and kind of play with this example, go over the code we talked about today, and make sure that you understand it, and it's always available for you. So awesome. So the last thing, I think while we're doing questions too, I think there's one more mystery with the flows that is kind of out there. And one is like, how did that get signed? How did like, yeah, sure, party A initiated it and sent this to the owner, which I said was party B. So we can intuitively remember how this initiator flow works. It opened up a flow session and then sent that transaction for a signature here. But how was that handled? That was handled in the responder. So the responder is just a regular flow. It extends flow logic, but it's annotated by this special initiated by annotation, which is paired with the initiator class. So in the CorDapp that you create, you will pair together initiator and responders, and that's going to be the code that proposes the transaction, builds the transaction, sends it across the network, and the code that receives the transaction and launches a subflow to sign it. Now, in addition to that, you're able on the receiving end to put in your own constraints. So maybe the contract says that the amount just has to be greater than 0, but I'm like a super rich dude. Like I'm multi-billionaire, like a Bill Gates level times 1,000. I don't want to deal with any tokens like that are less than like 100,000. If you send me 50,000 tokens, like I don't really care. I don't want to sign that. I mean, I don't want to like be in really like want that at all. So I can reject it right here. When it comes for a collection, it'll automatically run the contract, but then after the contract, it'll look for, before you sign it, it'll go through this check transaction and you can put in custom constraints here. But then if it passes this, because there's no constraints entered right now, it's going to automatically sign, send it back, and then kick off this receive finality, which will just put the node in a waiting state until this finality flow with the notary uniqueness consensus, notary approval, and then the sending off for ledger rights, it'll just receive that. So that's how it works. That's the basic crux of it. Now, I'm going to stay here for questions for probably like another 5 minutes, but I'm going to wrap it off for people that have to leave because I know this went way overtime, like 45 minutes overtime. Really sorry about that. Thanks so much for sticking around for the first ever like bootcamp condensed webinar. I hope it was informative. I hope things went well. Yeah, and I hope everybody learned a lot. So if you got to go for it. See you later. Keep in touch with us, Slack, Twitter, etc. Reach out and keep building those CorDapps. From where you are right now, you can definitely build anything and just incrementally get better and better. And if you have any questions, reach out to Devrel. So I'm going to keep answering questions too. So contracts in Corda are like smart contracts. So in a sense, I would say if you're familiar with like other platforms such as like Ethereum, etc., the concept of smart contract encapsulates like the whole application. So an Ethereum smart contract that you might program in Solidity would deal with not just like state representation or the facts, but it would also deal with like basically doing things like querying oracles and also building in business constraints like the checks, et cetera, et cetera. So their smart contract is sort of like our CorDapp. So like our whole CorDapp. But our CorDapp is modular in that we basically abstract it to states, which basically define the fact, contracts, which constrain or guide the evolution of that fact, and then flows, which are actually the logic and the sequence, the algorithm of the application itself. So that's the difference there. If you go out and just go to your regular bar, like Bitcoin meetup, and you start talking smart contracts, they're thinking like basically analogous to the whole CorDapp. But when we say contract, we're talking about this specific component that enforces the business logic. Does that make sense, Sonia? Yes, I'm assuming yes. Oh, wait, she's typing. And Sumit, thanks so much for saying it's a superb session. I'm really glad you enjoyed it. I'm going to run more of these. Like our whole team is going to run more of these if you guys really liked it. So probably just like a few more minutes, maybe 3 or 4 minutes of questions, feedback. Tell me if you hated me. I've never heard my voice. Maybe it's really annoying. Joseph is typing. Thank you. You enjoyed it. Yeah, recordings will be available. Hopefully they'll edit out that like 10 minutes where I couldn't get the test to pass. But no, actually, I think it would be pretty fun if they left that in. Yes, recordings will be available, so you can go over it again. Also, if you have any comments or things that we could improve or suggest, really love the feedback as well. We hope to keep you guys on this journey with CorDapps and keep you building. If you don't mind, can you tell me how did you deploy the jar on Corda node? Okay, so when we did the deploy nodes task, all that was handled for us actually. So on the deploy nodes task, what we have here is project CorDapp deploy true. So that basically said that we're deploying this whole CorDapp, the whole project that we worked on, and it did it automatically. Now, if you wanted to say deploy nodes, so you had your mock network set up, and you know that that mock network's persistent, so you can keep running transactions on it as long as you don't deploy again. If you wanted to add more apps, you can drop your CorDapp jar. Like you can basically compile your jar and drop it into the nodes CorDapp directory. So if you're following me on my code screen, this build directory, remember build nodes is where it put all those different nodes that we defined. And if I go into an individual party, I have a CorDapps directory that has the jar of the one that we just built and deployed. Now you can drop jars in there, rerun your nodes, and then you'll be able to deploy, right? So slightly different process if you're going into like production or like et cetera, but all the documentation for what you need to know is on docs.corda.net, or you can Slack us or email us any additional questions. So where's it? Is there another question? Somebody said there's another question. What's the question? Do we run deploy nodes after each change to test? So yes, like the thing is if you change your CorDapp, in like basically you have two options here. So if you change your CorDapp, obviously the jar that was compiled and placed on your original deploy nodes is not the same one anymore. So we need to regenerate that. So your two options are to redeploy, so deploy nodes again, but then remember that you're going to lose the transactions that you had stored. So your other option is just to build, like just do a jar build on your app, and then drop that into the CorDapp directory and then rerun. So remember that run node script that actually brings up or instantiates the nodes that were deployed previously. So you have two options. And this is just the tip of the iceberg. You don't have to always use deploy nodes for testing. If you download one of our templates or one of the samples from GitHub Corda/samples, you'll notice that they have basically drivers, like preset drivers set up where you can run in-memory networks. So you can run mock in-memory networks. If you look through our testing classes, the ones that we used in our little bootcamp here, those testing classes rely on an in-memory tooling for test networks. So like there's like a mock network class. So you're able to build tests like that, etc. So you have several options. And as like a really cool option, you can download like our VS Code extension, which will allow you to test CorDapps and actually execute flows in your VS Code Studio, in your IDE through that extension. Additionally, we will be releasing at some point an extension for IntelliJ as well, and some other tooling. So our goal this year is to do a lot of tooling to help you develop efficiently and to help you have a lot of fun while you're making CorDapps. So keep looking out for changes. But if you go through the documentation and through our samples, you'll see a lot of options for how you can test these. Awesome. So, okay, so I think in 2 minutes, like I'm gonna wrap it up 1 minute. So I'm gonna say my adieus. I don't know if you guys need anything else. Any more questions? You want me to sing a song or something? Tell your friends about this experience, whether you liked it or not, because you know it's only gonna get better. I'm sorry, like we kind of like threw this in as a rush. It was a last minute thing, but knowing how things went this time is beneficial, and just the feeling of going through it is going to mean that next time it's going to be 300% better. And then hopefully we can start baking in more advanced topics as well, because I know you guys are well on your way. You're on your journey. So the next time we all meet together, you'll probably have a lot of knowledge and want to go a little bit deeper and go big or go home. Like build your core apps, change the world. So that's going to be me, like, signing off. Thanks, everybody. Big shouts to Robert, to Tiffany, Edgars, Eric, Chris and Peter for keeping things running and making everything go smooth. Thanks so much for being here. I'm going to sign off. I'm Anthony. Follow me on Twitter at anixon604. Thank you, guys.